Hi, Doc Revis here with Watch Me Work It. Combustion analysis calculations of an amine having C, H, and N. So here's the problem. The combustion of 11.014 gram of an unknown compound contains only carbon, hydrogen, and nitrogen, with 10.57 grams of oxygen was gas gave 12.923 grams of carbon dioxide and 6.608 grams of water. Treatment of the sample with hydrogen gas gave 2.501 grams of NH3. So, problem number one, find the empirical formula of the hydrocarbon. And we know this hydrocarbon contains C, H, and N. What is empirical molar mass? Meaning, we need to find the smallest whole number unit, called the empirical formula, and then we can calculate the molar mass of it. And how many repeat units if this compound has a molecular mass of 87.87, no decibels, 87 gram per mole. All right, so we go to the problem. What we need when we're doing empirical formulas, we must have moles. That's our target, moles. We look at the problem, we don't have moles. We have grams, 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 and grams, which means we're going to have to do some conversions. Well, we'd like to have the grams of carbon, but we don't have it. But we do have the grams of carbon dioxide, CO2, so we can indirectly get to carbon. We don't have the grams of hydrogen either, but we have water, H2O, as an indirect source. And we don't have nitrogen, but we have NH3 as an indirect source. So let's get going with finding the carbon then. What we're looking for are the moles of carbon, hydrogen, and nitrogen. And we're going to compare the ratios to determine our empirical formula. So we have carbon here. And so we'll put the grams of carbon. We'll start 0.9, and we're going to do conversions. Grams of CO2 times bar, grams on the bottom, CO2, because that's what math says. Then the relationship swings up to the top. And so we have gram per mole of CO2. And this is going to be CO2. Then we do times bar, mole CO2 on the bottom to moles of carbon on the top. This is our interconversion factor here, where we go from one species to the other. And that's what we need, moles of carbon. So now we can go back and put the units in. The gram per mole of CO2 is 44.00. I know that because I have 1 times carbon's molar mass and 2 times oxygen's molar mass. I add these together and I get 44 by using the periodic table values. So that's 44.0 gram per every 1 mole of carbon dioxide. Next, I look for the interconversion factor. So I know I have 1 mole of CO2 and I only have 1 carbon in it. I just simply read it, count it, and it's there. And so it's 1-to-1 molar ratio here. So if I run these numbers through my calculator, I get this value for the moles of C. These are moles C. Let's do similarly for hydrogen. Hydrogen, our source of hydrogen is 6.08 grams, 6.608 gram of H2O. So it's an indirect. So since it's indirect, I'm going to use dimensional analysis to convert it. It's H2O to every mole here, and the mole of water. And then dimensional analysis says, put this on the bottom. That's a math rule. And then we look for the ratio of mole of hydrogen on the top. So let's go back and put these values in. So we have 18.00 grams to every 1. I know that because it's 2 times H plus 1 times O from the periodic table, and I get 18.00 gram per mole, all by using periodic table values. Next, we take a look at the molar ratio. For every 1 mole of water, I have 2 moles of hydrogen. How do I know? There's a big 2 in it, H2O. So that's the ratio. So now I take these values, I punch them through in my calculator, I get this number of moles, 0.7342 moles of H. Okay. Well, next I need to do that for nitrogen. The source of nitrogen is here, 2.501 gram of NH3. So 3 times that, times bar on the bottom, and we get gram NH3 on the bottom here, and we have mole on the top. And then we're going to do the inner conversion, mole of NH3. And this is going to be mole of NH3 on the bottom to mole of N. And I'll have moles of nitrogen. So let's see what we have. So grams per mole of NH3 based on molar mass of NH3 is 17 grams per every 1 mole. The relationship here is for every 1 mole of NH3, we have 1 mole of nitrogen. So if we punch these numbers through on a calculator, we get 0.1471 mole of N. Next step, because we're doing empirical formula, is to divide all these by the smallest number of moles so we can get the ratio in small whole number units. We don't use fractions. If we get fractions, we use mass to convert them to whole numbers. We punch these numbers through for carbon, we get a value of 2. Here we get 5, and here we get 1. And therefore, our empirical formula, I'm going to write it right up here at the top, is C2H5N. That's my empirical formula. So the next thing asks, what's the empirical molar mass? Well, this is 1 carbon times 12, and this 5 hydrogens times 1 is 12.0000, and 1 nitrogen, okay, here, and that's going to be times 14. And when we add all this math up, we get 43.00 gram per mole. So how many repeat units do I have? Well, the number of repeat units in this would be, take the 87, okay, gram per mole, divided by the 43.00 gram per mole. And when I run this number through, pretty obvious, right? I get 2 repeat units. So my molecular formula for this compound would be times 2. So I would take this and I would say times 2. If I do that times 2, I will get C4H10N2 for my final molecular formula. So there you have it. Combustion analysis, CHN.